Welcome to the Chapter 6.4 lesson video. We're going to talk about solving inverse equations with a calculator today. So either open up Desmos or get a calculator out. It's going to be really important as we do these problems. There's a lot of calculations involved and stuff you sort of need to be able to plug in and see for yourself. We'll practice it more in class as well, but it's an important thing for you to practice as you watch and see these examples. So let's go get started. All right, I can solve trig equations algebraically for a selected variable. So if I say solve for x or solve for y or whatever it is, you can solve for that variable. Make sure you know that to undo sine, you use inverse sine, or to undo tangent, you use inverse tangent or arctangent or whatever it is. You can use those inverse operations to undo one trig function for another. And then we can use our calculators for non-familiar reference angles. So if we have something that sine of theta equals 1/4, that's not one we know, but you can still use a calculator, do inverse sine of 1/4 on your calculator and figure out what those reference angles are. All right, so solving for x in terms of y. All right, so find an expression for x using an inverse essentially just means solve for x. So we're going to try and get x by itself, order of operations in reverse and undoing stuff just like we normally would. Just when you come to the trig function, you're going to undo cosine with inverse cosine, tangent with inverse tangent, secant with inverse secant, and so on as we go. So first thing we're gonna do, I'm just gonna add a little parenthesis here. This is cosine of 2x, so we should have that there. So we want to get the x by itself. So the first thing we're gonna do is divide both sides by 3. So we get y over 3 equals the cosine of 2x, still in parentheses. And then I got to get to that x, so I got to do the next most out thing, which is the cosine. So I'm going to do inverse cosine of both sides. So I'll get inverse cosine of y over 3 equals 2x, and that's not too crazy, right? To undo the cosine, we used inverse cosine on both sides. On the right-hand side, so essentially what we did was this. We did inverse cosine, and on this side, they got rid of each other, leaving us with just the 2x. All right, so then last thing, if we want to get the x by itself, we divide by 2. So we'll end up with x equals the inverse cosine of y over 3 divided by 2. And that's our answer. That's where we're at. Awesome. Okay, so that's one type of problem we'll run into. Another type of problem we'll see on the next slide. All right, so these ones, they say solve, so that usually means solve for the only variable, which would be x in this case for both of these problems. So we're going to solve for x. You're just trying to get x by itself, and then you'll evaluate whatever you can on the other side. So our first example here, we'll go ahead and start dividing the 2 over. So we'll end up with arc sine of x equals pi over 2. And then I don't really like arc sine. I think it's kind of a pain, so I'm going to change that to be inverse sine. It's the same exact thing. It's just another way to write it and say it out loud, so I'm going to change it to that. And then just like before, when I undid sine, cosine, I did inverse cosine. So to undo inverse sine, I'm going to use normal sine. So I'll take the sine of both sides, and I'm left with x equals the sine of pi over 2. Hey, I can evaluate that, and a lot of these you'll be able to evaluate. So make sure you evaluate if you can. Pi over 2 is 90 degrees, so the sine of 90 degrees will say x equals 1. That's our answer. All right, so the next one, same idea. We're going to try and get that x by itself, so I'm going to use cosine on both sides. You could kind of do this one in a couple different orders if you want. But I'll do it this way. I'll say x equals the cosine of the inverse sine of 1/2. All right, so now I need to do order of operations. So I'll do this inside piece first. So the inverse sine of 1/2, maybe I'll draw a little picture off to my side. So that's positive 1/2. This is just evaluating here. This isn't multiple answers. So the inverse sine of 1/2, so that's 1, 2. That's a 30-degree angle. So I have x equals the cosine of 30 degrees then. And then using that same picture, this adjacent side is root 3. So the cosine of 30 degrees is root 3 over 2. So I got x by itself, and I evaluated what was left over, order of operations style, to get my final answer. Okay. So let's go ahead. We got two last examples to do. And these ones you can see from the title at the top, it says solving ugly equations. So what's going to be weird about these ones is when we get to that part where we take the inverse sine of both sides, it's going to be, like it says, an ugly number. It's going to be something that we don't know a reference. It's not going to be 30, 45, 60. It's going to be an ugly one. So we'll go ahead and divide by 4, and we get the sine of 3x equals 1 over 4. Now, I know we've seen something a little bit like this before, but not quite, because this time we also have that period change in there of the 3x. So we know sine is going to be positive 1/4 twice, because sine is positive stuff twice usually, other than positive 1. And so we know it's going to happen twice, but then we have this times 3, so there's actually going to be 6 final answers. So let's go ahead and let's find the first 2 answers. So I'm going to go ahead and I'll draw these angles. I'm going to draw the triangles where sine is positive. And 1/4 is okay because it's between 1 and -1. And then I'm going to pull out my calculator, and I, in my calculator, am going to do the inverse sine of 1 over 4. So I'll plug that into my calculator. I'll get inverse sine of 1 divided by 4, and I get, make sure it's in degrees mode, and I get 14.5. 14.5. It's, remember, when you plug in your calculator, it'll give you positive signs in this quadrant and negatives in this quadrant. So I put the positive one here, 14.5. That's my reference angle. So to find this angle over here, I'm going to do 180 minus the inverse sine of 1/4. So I'll do 180 minus that 14.5, and I'll get 165.5. So 165.5 to get that other angle. So all right, so I have my two my two angles here of the first two, but those aren't my actual answers. If it was just 4 sine x equals 1, those would be my answers, but it's 4 sine of 3x, so I have to do the whole period change thing we talked about in the 6.3b video. So there's going to be 2 of them. I'll go 3x equals 14.5 plus 360n, and I'll say 3x equals 165.5 plus 360n. So I'll divide everything by 3 there. So 14.5 divided by 3 is 4.8, or about 4.8. So I'll say x equals 4.8 plus 120n, and I'll do 165.5 divided by 3 as well, and I will get x equals 55.2 plus 120n. All right, so I have my 2 formulas to help me start generating all my answers. So I'll go ahead and I'll write out my final answers. So I have x equals, and then the first 2 are right there. They're easy for me. 4.8 and 55.2. And then I'm going to add 120 to both of those. So I'll get 124.8 and 175.2. And then I'll add 120 again. So I'll get 244.8, and that would be 295.2. Now, if I added 120 again to either of those, I would go over 360. So that'll be it. Those will be my final answers. And just like we predicted at the beginning, there are 6 answers here. 2 times 3 made 6 answers. And we found them all. So a little bit of a pain just because of all the calculator work, but not entirely impossible. Similar idea, let's go ahead and try the next one. So we have tangent of x equals -2. All right, well, tangent will be negative in these 2 quadrants. All right, so it's going to give me a reference angle. And just remember, when we plug in our calculator, tangent goes quadrant 1 and 4. So it's going to give me this reference angle as a negative, which I'll have to add to 360. So I'll go ahead and in my calculator, I'm going to go ahead and do the inverse tangent of -2. So in my calculator, I do the inverse tangent of -2, and it spits out -63.4. Now, I know that it's talking about an angle in this quadrant, but I'm finding my answers from 0 to 360. So negative 63 isn't good. So I'm going to add 360 to that. That'll give me my first angle, which is 296 point. Oops, I wrote that wrong. 296.6 degrees. And then I would do the same thing except with 180 because it's the same reference angle, so like a 63-degree reference angle. So I'll do 180 minus that 63.4. So 180 minus 63.4, and I'll get 116.6. 116.6. 116.6. Now, if you notice, this one doesn't have any period modifiers, so those are just my two answers. So I'll go ahead and say x equals 116.6 and 296.6 degrees. All right, so that should be able to get you started on the assignment for this lesson. If you have any questions, please reach out to me. Otherwise, I'll go over this more and I'll see you in our next live session. Until then, I hope you have a great day.